Okay, so yeah, Ravi Teja,
Yes, sir.
Jaya,
Yes, sir.
is joining or not?
She is coming, sir. She will join. You can continue, sir.
Okay, okay, fine. So let's start. Let me share my screen because it's already like 4:25. So let's
Yes.
start. Okay, fine. So yes, can you please confirm? Is my screen visible?
Yes, sir. It's visible.
Okay, fine. So in our last session, we completed the word embedding technique that is called bag of word. Okay, so now let's continue with the TF-IDF, and this is the second technique that we have to convert the textual data into the numeric format. So can anyone tell me a little bit about the bag of word technique and why we need a bag of word technique? Yes, in our last
To
session,
count how many
Mhm.
to count how many particular values are there in the unique, like three sentences or n number of sentences, and get a particular non-unique words from them. How many are there without stop words?
Okay, no, I'm talking about the definition. So here, as you can see, like in this particular sheet, I mentioned bag of word technique, or we can say the model is a simplest form of text representation in a numbers. So whatever the textual data that we are getting in the form of corpus, in the form of sentences, in the form of words, with the help of bag of word technique, that we can convert our textual data into the numeric format. Numeric format with the help of bag of word technique. So here, let's say we have some sentences like sentence 1, sentence 2, sentence 3. So first of all, in this particular sentence, all the sentences, first that we need to convert into the lowercase, then we can apply stemming or lemmatization to get the base word from the our data. And after that, we can apply the stop words to remove all the stop words from our data set. And then we can apply the bag of word technique to get the textual data into the numeric format. Okay, so simply you can say, okay, so bag of word is a technique that we can convert a textual data into the numeric format. Now we have some of the disadvantage. As I mentioned, we are not getting the idea, okay, so in which word that we need to focus on. Okay, so as you can see, like we have the data only 0 and 1. So in this case, we can't say, okay, so in which word that we need to focus on. We need to focus on good or boy or good. Okay, so this is the some disadvantage that we have in a bag of word technique. That's why we have the next technique that is called TF-IDF. TF-IDF. TF stand for term frequency inverse document frequency. So TF, if I write here, so TF IDF, IDF, TF IDF. So term frequency, IDF stand for inverse document frequency. Okay, so term frequency inverse document frequency. So this is the full form that we have for TF-IDF. This is the again one of the technique to convert the textual data into the numeric format. But what happened here, you can see we have the definition. One problem that we encountered in the bag of words approach is that treats every words equally. So as you can see, we are getting we are treating all the words equally, like good, boy, or girl, because we are just representing in the form of 1 or 0. So that's why here the formula that we have. One problem that we encounter in the bag of words approach is that it treats every word equally. But in a document, there is a high chance of the particular words being repeated more often than other. So to solve this particular problem, that we use a TF-IDF, term frequency inverse document frequency. So here we are getting the data in the numeric data in the form of 0 and 1. Whenever we apply TF-IDF, we are getting the output like, let's say that we have the good. So we can focus on good data. So we can get the output like 0.99. Okay, 0.99 for the boy that we will get. So if I write here, so let's say the data that we have here, good boy and girl. Now, right now we are getting the data like 1, 1, 1, 0, 0, 1, 1, 0, 1. Let's say this is the data that we are getting for bag of word, for bag of word technique. Now, let's say if I'm going to apply here TF-IDF, TF-IDF. So what happened in a TF-IDF technique? Whatever the data that we have, like good boy and girl. So let's say if I'm going to focus on this particular good. So for this one, we will get the numeric data like 1. Let's say if I'm going to focus on, I'm going to less focus on this particular point. So here we will get the output like 0.2, 0.5, like this one. Okay. So as compared to, let's say if we compare 1, 0.2, 0.2 and 0.5. So we can say the highest number is 1. Can I get yes or no? Highest number is 1, right? Why 1? Because in a 1, we are going to focus on more. Okay. So that's why here we have good. Good, it means that we are going to focus on this particular point rather than boy or girl. So in a IDF, in a TF IDF, turn frequency, inverse document frequency, we are getting the data in the form of points, in the form of points we can say, or we can say in the form of frequency. Okay, so that we can do the comparison. Okay, so in which word or in which sentences that we need to focus on. So let's say if I'm going to write one sentences, okay, so I love apple. So let's say if we want to convert this particular data into the numeric format, so can you give me the some value how that we can represent this particular data? I love apple. So we need to focus on love, or we need to focus on apple, or we need to focus on I. Just let me know once in the chat, everyone. Do we need to focus
Apple,
on
sir.
love, apple, or I? Yes, come again, Ravi Teja.
Love, I think, sir. Love.
Yes, so we need to focus on love. Why? Because we can say this is the positive point that we have, right? Positive word that we have in this particular sentences. So we can assign this particular value like 1, and the rest other point that we can define less than 0. So let's say 0.8, and here we are going to say 0.2. As this is the, we can say this is the stop words. So that's why we are going to define 0.2. Now let's say another sentence that we have. So this mobile phone is not good. Not good. Okay. So now let me know, like for all the words, just let me know the positive word here. Positive or negative word from this particular sentence. Positive or negative word, just let me know. This mobile phone is not good.
Negative, sir.
Negative. Okay, negative, but for which word that we need to assign negative? Not,
Not.
right? Not, that we need to assign negative. Now, just let me know how we can assign the numbers here, how we can convert this particular entire sentences into the numeric format. So we can say, let's say for the this again, this is the stop word. So let's assign 0.2. Again, each is a stop word. We can say 0.2. Mobile phone, let's say like we are going to assign 0.8. 0.8. Again for phone 0.7. Again, not good. So again, this is a negative sentence. So we can say 0.3. Let's assume less than, like whenever we have the less than 0.5, we can represent negative, and whenever we have greater than 0.5, we can assign positive. Okay, so as this is the negative word that we are going to assign 0.3, and again good that we need to assign greater than 0.5 or less than 0.5. Yes, everyone. We need to assign less than 0.5 or greater than 0.5. Yes,
Less than
Ravi Teja?
0.5.
Less than 0.5.
Yes, sir.
Yes, correct. Less than 0.5 because we need to connect with the previous word. We need to connect with the previous word. So here that we have this mobile phone is not good. Not good. Okay. So that's why we are going to say, let's say this is the 0.4. Little bit like, we can say like little bit above number that I'm going to assign for this one. Okay. So 0.4 that we are going to assign. Okay. So here our machine, they easily get the understand. Okay, so for the negative words, that we are going to assign the less frequency number. Less frequency, it means the like 0 point less than 0.5 numbers, and whenever we have the positive words, we are going to assign greater than 0.5. Okay, so TF-IDF, it means that we have the number in the form of points in the form of frequency. Okay, so same thing that we have mentioned here. Okay, so in a bag of words, that we are getting the equal value for our all words. That's why we are not able to classify, and we are not able, as a human we can easily point out, but as a machine, our machine, they will not get the understanding. Okay, so in which word that we need to focus on. Okay, so turn frequency TF-IDF give us the measure that take the importance of the words. Here as you can see, we are going to provide the importance of the word for this particular love. That's why we are assigning here the one value. Okay, so TF-IDF give us the measure that takes the importance of the word into the consideration depending upon how frequently it occurs in a document. It occurs in a document, it means how many times it's available in our data. So TF stand for term frequency, inverse stand for like inverse document frequency stand for IDF. Okay, so this particular point is clear. Definition by this particular point is clear, guys. TF IDF.
Yes,
Yes,
sir.
no.
Yes, sir.
Okay, fine. Now we have the, as we mentioned, 2 points, TF and IDF. Now let's try to understand how we can calculate TF IDF. TF and IDF, how that we can calculate. So TF, term frequency, it measures how frequently a word appears in our data. Our words appears in our data. So we have one formula, and based upon the formula that we calculate. Okay, so here as you can see, we have the formula, number of the times terms appears in a document divided by total number of items in the document. Okay, so let's say if you want to calculate, okay, so whatever the words we have in our sentences. Okay, so if we want to calculate, okay, so how many times the particular words appears in our data set or in our sentences, so with the help of this particular formula, easily that we can calculate. So here as you can see, we have one word. So let me open my pen. So here we have one word, cat loves to play the ball. Okay, so here let me open the pen. It's opening. Yes, so here you can see we have one data, cat loves to play the ball. So if we fit this particular entire sentences based upon this particular formula, so we can say how many total number of words that we have, total number of items in the document. So 1 2 3 4 5 6 7, we can say total number of items or total number of words appears in our data, in our sentences is 7. Now let's say if we want to find out how many times cat available in my data. So how many times cat available? Only one time. So we can say 1 1 1. Yes, number of times terms appears in the document. So if we are going to calculate the cat, so cat available only one time divided by total number of items in the document. So how many numbers of items that we have in our data? Total is 7. So 1 by 7. Okay, so here we have the calculation mismatch. 1 by 7 that we need to write here. Okay, so 1 by 7. So on whenever we apply in our data set, we need to calculate. Now let's say here we have the new sentence that is called, let's say the dog sat on the log. Now let's say if we want to calculate for sat, just let me know the output, final output. Just let me know the final output, guys. Sat, term sat, we need to calculate the turn frequency. Yes, everyone?
0.166.
Point, no, first let me know the output like this one, then you can calculate into the point.
1/6, right?
1/6, sir.
1/6. And what is the point output?
0.166.
0.166.
166.
Okay, you can calculate from your end. Okay, so I'm not going to do the calculation. Now, what about this one? 1.7? 1.42 something?
0.142.
Okay,
0.142.
0.142. Okay. 0.142. Okay, so as you can see, whatever the data that we are getting into the frequency table that we are getting. Okay, same what we can do, whenever we can calculate, we can fit into this particular formula that is called number of items terms appears in the document divided by total number of items available in our entire sentences. Document, it means I'm talking about the sentences. Okay, now inverse document frequency. Second, that we have inverse document frequency, that is called IDF. Okay, so IDF mainly measure how important the terms across all the sentences or across all the corpus. Okay, so it measures the importance of the word in the corpus. Okay, so here as I mentioned, I love apple. It means love is a more important word that we have here as compared to apple and I. Okay, so with the help of IDF, that we are going to calculate or we are going to measure the importance of particular word in our corpus. Okay, now if I talk about the formula for this one, so we have the formula like log of total number of documents divided by number of documents with term in it. Okay, so number of documents in our term. Now let me calculate, then you will get the more idea. Okay, so what I'm going to do, let me jump here, and here we have one sheet that is called TF-IDF. So again, I'm going to take the same example. Okay, so first sentence that we have, he is a good boy. Second sentence that we have, she is a good girl. Third that we have, like boys and girls are good. Now what we are going to do, first of all, we need to find out the unique word. So again, same unique word that we have, good boy and girl. So here you can see good boy and girl. Now, first we need to convert into the lower sentences. We need to apply the stemming lemmatization. We need to remove the stop words. Now for the sentence one, we are getting the output. After removing the stop words, we are getting the output like good and boy. Second, that we are getting good girl. Third, we are getting here like boys, girl and good. So here we have the boys, girl and good. Okay, so boys, girl and good. So this one that we are getting, yes, no?
Yes, sir.
Yeah.
Okay, fine. So as you can see, based upon this one, we are getting the unique word. Now we need to calculate two things. First, we need to calculate TF, that is called turn frequency. Second, we need to calculate IDF, that is called inverse document frequency. Okay, so TF that we have, turn frequency, number of representation of the words in the sentences divided by total number of words in a sentences. So this is the formula that we have. This is the entire formula that we have. Same formula that I have mentioned here. Number of items terms appears in the document divided by total number of items in the document. Now we are going to do the calculation. So for the sentence 1, we are talking about good. For the sentence 1, we are talking about good. So how many times this particular good available in this particular sentence? 1 by 2. We can say total number of data is 2. And how many times
Yes,
good
sir.
available? Here good. 1 time. So 1
One
by
time.
2, we can say 1 by 2.
Yes, sir. 0.5.
Yeah. So we will talk about this one point later. Now, right now, focus on this one. So 1 by 2. Now, if I talk about for the let's complete sentence 1 first. Now, boy, how many times boy available here? 1 time. So again, we can say 1 by 2.
1 by 2.
Girl, 0 time. So here we have the 0. Now for the sentence 2, here again, how many times good available here? Sentence 2, 1, 1 by 2. Boy 0, so 0. Girl 1 by 2, so 1 by 2. Now for the sentence 3, total number that we have, total number of words that we have here is 3. How many times good available? Only 1 time. Boy available? Only 1 time. And the girl available? Only 1 time. So 1 by 3, 1 by 3 and 1 by 3. We are able to calculate the TF, turn frequency only. Now let's calculate the IDF. IDF. So as you can see, the formula say, if I show you the formula again, log of number of the sentences, it means total number of the sentence that we have is 3 divided by number of the sentence containing in a word. Number of the sentences containing in our word. Okay. So total sentence, if I talk about the good. So how many sentences that we have total? We are talking about the good. So how many total sentences that we have as for this particular formula? Number of log of. So let's write log of how many times number of sentence. So how many sentences that we have here? Total 1, 2, 3.
Yes, sir.
3 divided by number of sentence containing in the word. So how many sentence, in how many sentences we have the good word? In how many sentences we have the good word? So we have the good word in sentence 1, we have the good word in
3
sentence 2,
sentences.
and we have the good word in a sentence 3. So we can say 3. So log of 3 by 3, 0. Like 1, we can say log of 1 is 0. So we are getting the output that is called 0 here. Okay. Now, if I talk about the boy, so we have the number of the sentences again same. So log of 3, boy available in first sentence and the third sentence. So 3 by 2 we can say 3 by 2. You can write it down the final output here. Now again same for the girl, 3 by 2. Right? Clear this particular point? How to calculate the TF and IDF? TF and IDF? Clear?
Yes, sir.
Okay, fine.
Yes, sir.
Now, what you can do? So, down. Now we are going to calculate the final output that is called TF-IDF. TF-IDF. So here we have the final formula. Okay, so we don't have here. So like what we do to calculate the TF-IDF, we just need to multiply. To do the final calculation, we just need to multiply TF into IDF. TF into IDF. So here for the sentence 1, for the good word, we have the 1 by 2. We have the 1 by 2. So I'm going to say 1 by 2. We are talking about the good word and sentence 1. 1 by 2 into 1 by 2 is TF. So here we have the TF into IDF. So for the sentence 1, good, we have the IDF is 0. So we are going to say here 0. So 1 by 2 into 0 equal to 0. Now, for sentence 1, we are talking about the boy. So for the sentence 1, we are talking about the boy. So 1 by 2 again. And for the boy that we have 3 by 2. So you can just do the calculation for this one. Let me know the output, guys. Let me know the output here. Or let me do in this way. So 1 by 2 log of 3 by 2. So the final output that we will get 0.08. You can just do the calculation. Here you can see that I have the calculation. Okay, so in this way that we can do the calculation. Now for the girl sentence 1, so 0 into log of 3 by 2, we are getting the output is 0. So here we have the 0. Clear how we need to calculate TF, IDF and the final TF, IDF?
Yes, sir.
Can I get yes or no?
Yes, sir.
Okay,
Yes, sir.
fine. Now what I'm going to do, just take the pen and paper. Okay, just take the pen and paper and I'm going to provide you the 3 sentences. This is the sentence. Let me put it down in a group as well. Yes. So take the pen and paper and calculate the TF, IDF. Here you can see the formula and all. TF, IDF. Just take a pen and paper, do the entire calculation in a like paper. Okay. Take the screenshot or picture and put it down in a group. Or if you don't have the pen and paper, just create the Excel sheet like this one. Or Word, anything. You have the 10 minutes of the time. Everyone, just do it fast. 10 minutes only. As this is a very important a mathematical calculation. Okay. So that's why just do it once so that you will get the idea. Because if I talk about the coding part, so we just need to write 2 lines of the code for the implementation. But let's understand the first of all the topic and then we can do the implementation in 2 lines. Do it and let me know, guys. Yes, guys, can you please confirm it's done?
Yes, sir. Doing final TF
Okay.
into IDF.
Okay. Okay. Okay, so we have three things. Okay, so I got one output. Okay, so we have the sentence one: cat sat and mat. Okay, dog sat and log. Cat chased dog. Okay, TF calculation. So 1/3. 1/3 for the sentence one. One by three, 1/3, 1/3. No, like, okay, yeah, it's fine. Like, no need to define this particular zero. Without zero that we can use. No. It's a final output. Where is the entire solution? Ravi Teja. Okay. So TF 1/6. What is the formula for TF?
Number of total words divided by that particular sentence. How many times that word is
Number of
coming?
total number of words in a particular sentence.
Yes, sir. Six are there in that particular sentence.
So where is the sixth word? We have the three words only. If after like removing the stop words, we will get, if I talk about the first sentence, so we will get cat, sat and mat, right? If I talk about the third one, like second sentence, so dog, sat and log, right? If I talk about the third sentence, so cat, sat and dog, right? So we
Yes,
have
sir.
the
That
three words per sentence, right? So if we put based upon this particular formula, not here, let me put here. So how many unique word that we have here?
1/3 will get, sir.
One by
I
three,
forgot that is unique words.
right?
You
One
told
by three.
total number of words in sentences.
Yeah. So this
So I
calculation that you
thought
need to
we
modify.
have to take that particular sentence.
Yeah. So 1/3, 1/3, like everywhere that you need to write 1/3, 1/3.
Yes, sir. 1/3. Yes, sir.
Okay. Now let me check here. So no need to define this particular zero. Okay. We can calculate based upon the sentence. Okay. So if I write in this way, so let me jump here. TF calculation. Okay. So unique word, we can say we have the cat. We have sat and we have here mat. Okay, so actually we are doing the calculation like this one, so that's why we have the 0, right? Yeah, it's fine, no issue. So we can say 1 by 3, 1 by 3, 1 by 3, right? So 1 by 3, 1 by 3, and 1 by 3. Now if I talk about next, so next we have the dog, we have the sat, and we have the log, right? So cat not available, we can say here 0. Sat available, so yes, we can say 1 by 3, right? Mat available, no, so we can say 0. Dog available, so yes, dog available, we can
0.
say 1 by 3. Sat, again we have the
In
repeated.
sentence 1, sir. Sir, that is sentence 1.
Okay, sorry.
Sentence 1 cat is available, sir.
So here we need to write 1 by
Dog
3.
is not available. There
Sat,
only.
no, this is 0. Sat available, so yes, 1 by 3. Mat available, no, 0. Dog available, 1 by 3. This thing already added.
1 by
Dog available, so we can write 1 by 3.
1 by
Fine.
3. Next.
What about next? Next that we have cat, so 1 by 3. So next word that we need to write here, the chest. We need to define 0 here, 0 here, 0 here, 0. Now sat available, no. We need to write 0.
0.
Mat
0.
available, 0. Dog available, 1 by 3.
0.
Log available,
1 by 3.
0. Not available, na?
Not available.
Fine. So this is the final out. Sorry. This is the final TF, TF that we will get,
Yes, sir.
right?
Yes, sir.
Now show on that we need to calculate for IDF, right? So again for the IDF, the output that we will get like log of 3 by 2. So if
Yes, sir.
I write the same thing, like let me copy and paste. Right. And if I copy this particular word, okay. So log of, for the cat,
3
how
by
many
2.
times cat available?
2 times available, sir. 3
2
by
times,
2.
right? So we can say 2 by 3.
Yes, sir.
What about
3
sat?
by 2, no, sir.
Total
You gave
number of
formula
sentences.
number of sentences divided by number
3
of
by 2. Yes. How many
sentences
times
containing
like
in word.
sat available? 2 time?
1 time.
Sat 1 time or 2 time?
Yes, sir. 2
2
times,
time.
sir.
Yes. What about mat? 1 time?
1 time.
Okay. What about like dog?
Dog is 3 by 2.
3
2
by 2.
times
2
available.
times available. Log 1 time.
And yes, sir.
Again changed
And changed
1 time.
also 1 time.
Okay. So if we will do the calculation, a final calculation that we will get like for 3 by 2, we can say 0.176, right? Again for next one, like if I do in this way, so next that we have 0.176, next 0.477, again for this one 3 by 2, so same. This one you can just check it out the final calculation. I'm just writing the figure. So 0.477 something, and same for this one. Okay, so this is, we are getting IDF. Now final we need to calculate the TF IDF. TF IDF. So now easily that we can calculate the TF IDF. Can I get yes or no?
Yes, sir.
Yes. So yeah, same way what you can do, you can just calculate the TF IDF for this one as well. Okay, now I hope you got the idea how that we can do the calculation for TF and IDF.
Yes,
Yes.
sir.
No?
Yes,
Fine.
sir. Yes, sir.
Now
Got it.
what we can do, so let's do the implementation. Okay, so for the implementation, right, we just need to write one lines of the code, nothing else. Okay, so here you can see that we are calling the scalar from scalar feature extraction dot text, we are going to import tf-idf vectorizer. Last time we called here count vectorizer. Count vectorizer. This time we are going to call tf-idf vectorizer. Okay. Now after that we are going to import the pandas. This is the corpus data that we have, like sentence 1, sentence 2, and sentence 3. 3 sentences that we have. We are going to create the object for tf-idf. Now after that we are going to transform. We are getting the features. Okay. And then we are going to convert into the matrix array. Now you can see we are printing our data. So first we are going to print all the features. So for the affordable, we are getting the value 0.414. For the and we are getting the data 0.41. Okay, 41. Now for the burger that we are getting 0.322. Delicious we are getting 0. Okay, no. So this is the wrong output. Let me represent in this way. It's not a wrong output, like I need to represent it this way, then we can call. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 1, 2, 3, 4, 5, 6, 7, 8, 9. No. So what happened here, as you can see, the data, sorry, whatever the data that we are getting, so we are getting into the next line data that we are getting. But right now, as you can see from this particular data, as we are not removing any stop words here. So these are the stop words and is not. Okay, so these are the stop words that we have. So that's why for this particular stop words, whatever the output that we are getting is a 0, 0, 0, 0. Okay, so for our all the stop words, the data output that we are getting, numerical value that we are getting a 0. Apart from this one, whatever the number, as you can see, this one 0.4, 0.3, and the so on 0.5. Okay, so we are getting for our other features, other words. But at the end, based upon this particular data, we can clearly say, okay, so in which word we need to focus on. Can I get yes or no? Based upon this particular data, we can clearly say in which word we need to focus on. Can I get yes or no?
Yes, sir.
Yes.
Not.
Right. Now, in a previous sentences, in a bag of word, as we are getting the data output, like numeric data, or we can say the numeric output in the form of 1 and 0. So here we can't say, okay, so in which word we need to focus on. But in a TF-IDF, we are getting a output data in a 0 point, like in a floating point value. So easily that we can say, okay, so in which word or in which sentences that we need to focus on. Clear? Why we need a TF-IDF and how that we can calculate it? Yes, no?
Yes, sir.
Purnima, please confirm it. Yes? Okay, fine. Now, this is all about the word embedding. Now, apart from this one, we have one more word embedding technique that is called word to vec. Word to vec. This one we will talk about later, because first you need to understand a little bit about the advanced NLP that is called RNN and LSTM. So we will talk about this particular point later. Okay. So another technique that we have, word to vec. But most of the time, whenever we are talking about like classification problem, we use word to vec, like TF-IDF or word to vec technique. Okay. Now what I'm going to do, so let me jump into the previous file. Okay, so this is clear now, word to vec technique. Can I get yes or no? Final?
Yes, sir.
Okay, fine. Now, let me jump into our previous file. So in a stemming and lemmatization, we just covered 2 points, stemming and lemmatization. But apart from the stemming and lemmatization, we have 2 more technique. Okay, we have 2 more techniques. So let's try to finish this particular technique. So one technique that we have, snowball stemming. Okay, one technique that we have snowball stemming, and another technique that we have Lancaster stemming. Okay, but yeah, most of the time that we are using stemming or lemmatization, but let's talk about little bit about these two methods as well. Okay, so snowball stemming. So again, this is the another technique that we have to get the base word, or we can say to get the root word from our data, from our words or from our sentences. Okay, so whenever we use snowball stemming technique, it reduce the data, it reduce the last few character from our words. So let's say one example. So we have the go, gone, going. Okay, so if I'm going to apply here snowball stemming, so it will reduce the last few characters from this particular three words, and the final output it will generate, that is called go. Okay, so again snowball stemming again is a part of the Porter stemming, or we can say the stemming. Okay, so it will reduce the last few character and then convert our entire words into the root word or into the base word, or we can say into the base form. Okay, so here this particular technique mostly we apply whenever we need a fast processing, because lemmatization if we are going to apply, so it will take a time to do the entire execution. If I show you, so here you can see this is the data that we have, and let me execute once from here. Okay, so if I'm going to execute here, so let me run till here, and then we can apply the lemmatization here. Let's wait a few minutes. Yeah, so now as you can see, I'm going to run this particular cell. Now as you can see, it's taking a time to get the final output. Now we are getting the final output here. Okay, now if we are going to apply here the same thing in our snowball stemming, so here what we are going to do, first of all we are going to import snowball stemming. We are going to create the object for snowball stemming, and we are going to pass our English data only, English word only, English data only. Okay, now after that, here we have some words like running, ran, and runs. We are going to create the stem word, because after the applying of the snowball stemming, I need to store everything in this particular empty list. So that's why we are going to create the empty list. We are iterating all the words one by one, and then we are going to run. So if I execute, so as you can see, within a few seconds we are getting the output. Let me execute again. So yeah, within a second that we are getting a output. Okay, so as compared to the previous Porter stemming, in a snowball stemming, we are getting the improved accuracy, improved output. It means correct base word that we are getting. Apart from this one, this particular snowball stemming, it support a multiple language. As you can see, right now we are calling English. Let's say if you have a data in a Chinese or French or some other language, you can just call the language and then you can create the object. So first advantage, it provides the high accuracy output. It means a correct base form output. Second, it support the multiple language, and third, easily we can execute snowball stemming. Execution time, if I talk about the execution time, so easily it processes the entire data and then it will generate the output in a few seconds. Okay, now same if I talk about the landscape stemming. Okay, so what happened in a landscape stemming? Again, first it will search the data. Okay, so it works as a search engine. We can say it works as a search engine. Okay, and whatever the data that we are going to stem, whatever the data that we are going to find out the root word. Okay, so mainly this particular landscape stemming we use in a sentiment analysis. Whenever we are building the sentiment analysis type of the problem statement. Okay, so we use the landscape stemming here, or we use the stemming only, Porter stemming technique, to reduce the word to get into the base word. Okay, so if I show you here, so as you can see, again we are using the Lance Carter stemming. Okay, now we are creating the object. This is the data that we are going to pass, and after that we are getting the final output: eating it, eats it, eaten it, puts put, putting put. So as you can see, the final base word that we are getting, base word. Okay, so this particular technique mainly be used in a sentiment analysis application whenever we are developing the sentiment analysis application. Again, it's totally up to us, but most of the time we are using landscape or we are using the Porter statement technique, because it will do the fast processing. Okay, and apart from this one, it will provide the, we can say, the high accurate base word as compared to the other methods. Okay, everyone, clear?
Yes, sir.
Yes, Ravi Teja?
Yes, sir.
Purnima? Okay, fine. So yes, this is
Yes,
all
sir.
about the basic NLP. Okay, now what I'm going to do, so anyone aware about the neural network? Because now we are going to jump into the advanced, little bit advanced topic, we can say.
Yes, sir.
Neural network? Yes,
Yes,
Ravi
sir.
Teja?
Yes, sir. Basic idea I have.
Okay, then what I can do, I will share one notebook. Okay, I'm going to, first of all, I'm going to record little bit point here. Okay, so let's discuss. But I'm going to share one notebook. So make sure before the next session, before the tomorrow session, try to go through the notebook once. Because what I observe, like you guys are not checking the notebook and just watching the classes, and after that you are attending the session. No, in this case, you can't develop any application, because I show your assignments as well and look like the similar assignments. Whatever the notebook I shared, the same types of the assignment I show. So it will be good. You can just do the modification little bit. Okay, and try to approach in a different way, because let's say if you are building the sentiment analysis, so build all the model, landscape, Porter stemmer, lemmatization, try to apply all the method, get the final output, compare it. Okay, so in which method better accuracy that we are getting. Okay, so do the implementation in a detail. Okay, now what I can do, let's talk about little bit about the NN, neural network. So let me create a simple architecture. Okay, so yeah, so can you please explain this particular architecture?
There are 3 input nodes and 2 hidden layers with 1 output node.
2 hidden layer,
1 hidden layer.
input gate, hidden layer, output gate, output layer, not gate, layer. Okay, so see, like this is the simple neural network architecture that we have. So what we are going to do, so in this particular neural network, we are going to pass a data. So let's say we have the 3 data, x1, x2, x3. So this is the 3 data that we are going to pass as an input to our neural network. Now again, under the neural network, just think about the any model like RNN, LSTM, CNN, okay, or the any CNN variant. Just think, okay, so this is the data we are going to pass to the NLP model to get the final prediction, Okay, now here you can see we have the data. We are going to pass x1, x2, and x3 data as an input layer. First, we are going to pass as an input data, this particular data, to our hidden layer. Now, whatever the data that we have, as you can see in this particular hidden layer, we have the total 4 node. Node number 1, node number 2, node number 3, and node number 4. Total 4 node that we have. Okay. So if I talk about the mathematical calculation, so in this way that we do the calculation, x1 into w1, it means input into weight plus biases. Okay, so here in between, everywhere we have the weight. Whenever we are going to pass this particular input data, so first that we are going to do the multiplication with the weight. So let's say here we have some weight like w1 dash, w1 double dash. Here we have the total 4 node 1, 2, 3, 4. So w2 dash, let's write 2 in this way. So w2 double dash, w3 double dash, triple dash, w3 4 dash. Okay. Now for this one, we can say W. This is the W2, na? W2. W3 dash W3 double dash. Okay, so whenever this particular double dash represent this particular line, this particular dash represent this particular line, so on that I have created the weight. So what happened when we send the data, input data via the input layer to our hidden layer, first we need to do the calculation x1 into w1 input data into the weight, then we can add the biases, and after that here we have the activation function. Here we have the activation function. So we send the data, input data, we do the multiplication with the weight. Okay, we apply the activation function to reduce the losses, and then we are getting the final output. So let's say we have one data, and this is the cat image that we have. So what we did, from this particular cat image, we created the pixel. So let's say, like, this is the image that we have. And in this particular image, if I talk about the pixel, so in this way that we are getting the pixel. So black one, as you can see, this is the pixel 1, pixel 2, pixel 3, pixel 4, pixel 5, and the so on everywhere that we have the pixel. Let me show you in one image. So CNN pixel image. See, I'm just going to provide you the overview. I'm not going to discuss in a detail. So just try to understand a little bit. So as you can see, if you want, we will discuss like in a detail in our upcoming session. But right now, just try to understand a little bit. So as you can see, like this is the images that we have, where we have the character that is called A. And everywhere we have some types of the pixel value. So as you can see, for this particular thing, we have the pixel value that is called 1.0. For this one, we have the pixel value 1.0. For this one, we have the pixel value 1.0. Now, again, for first one that we have the pixel value 1.0. For second one, so as you can see, this particular A character starts from here. Can I get a yes or no? This particular A characters start from here, as you can see, like this one, right? So here in this particular point, the value that we have 0.5, pixel value that we have 0.5. Now, whenever we have the black, deep black, we have the value that is called 0.0 only. It means this particular 0.0 represents the character. If we hide in this way, so as you can see, like if we do in this way, so here we have the 0, 0, 0. Just focus on here. I'm just trying to create the A. So I'm just trying to create the A. So it look like this one. Can I get yes or no? I need to change.
Yes, sir.
I need to change the color. Yeah. So it look like A, right? The previous image. So whenever, as you can just see here, so whenever we have this particular A, everywhere we have the 0, 0.0, 0.0. It means this particular 0.0 represents our main character. Apart from this one, other sides, as you can see, somewhere you are getting 0.1.0, 0.5, 1.0, 0.5, and so on, some other pixels value that we are getting. So on in this particular file, as you can see, what happened? Let's say this is the images that we have, and whenever I mention the black point, this particular black point, let's say this is the pixel value that I have. Pixel value that we have for the cat images. For the cat images, we have the pixel value. Now what I'm going to do, for this particular x1, I'm going to pass this particular value. For x2, I'm going to pass this particular value. For x3, that I'm going to pass this particular value. And so on, I'm going to pass for all the pixel value. All the pixel value that I'm going to pass a data. Let's say here that we have the xn that we are going to pass our entire pixel value. And then finally, we are going to calculate, okay, so whatever this is the training. We are talking about the training. Now, whatever the output that we are getting, so this is the cat or dog. This is the cat or dog. So let's say we are going to pass a cat data. After sending the data in the form of pixel, we are going to do the multiplication with the weight. We are going to apply the activation function, and whatever the output that we are getting, let's say this is the dog. But as we know, as a human, we are passing the data cat, but output that we are getting a dog. Okay, so this particular process, whenever we send the data in this way, so this is called a forward propagation. Forward propagation, it means we are sending a data as a input, we are sending a data to the input layer, we are going to do the multiplication with the weight. After that, we are getting a hidden layer to get the final output. So same that we have input data, we are sending, we are going to do the multiplication with the weight. Here we have the activation function everywhere, and then at the end we are getting the final output, that is called cat and dog. So whenever we are doing the forward processing, this is called a forward processing. It means forward propagation. Now same that we have the backward propagation. As we can see here, we are getting the dog, but we are sending a data as a cat. It means we need to do the backward propagation. Now what we do in a backward propagation? In a backward propagation, we update the weights. We update the weights. Whatever the weights that we have here, all the weights that we update. So whenever we have the rate symbol, this is the weight. So we update the weight. After updation of the weight, again we are sending the data to our updated weight. We do the calculation. We apply the activation function, and then final output that we are getting as a cat. Okay, so what happened in this particular neural network? As a data like x1, x2, x3, first we are going to do the multiplication with the weight, all the weights. Okay, so here we have the, let's say, the our hidden layer. We are going to do the multiplication x1 into w1, x2 plus x2, like let's say this is the weight that we have, w1, w2, w3. So x1 into w1 plus x2 into w2 plus x3 into w3 plus biases. Again here we have the x2. So w21, w22, w23. So x2 into w21 plus x2, w222, x3, w3, w222 plus biases. So in this way, we do the calculation, and this is called the forward propagation. Now, whenever we are talking about the backward propagation, so we just update this particular weight. We just update this particular weight to get the final output and to reduce the error. Because here we are sending the cat data, but we are getting the output as a dog. It means there is some error in our output, right? There is some calculation mismatch. Let's say calculation mismatch. So in this case, what we need to do? We need to update the weight via the back propagation. So whenever we go forward to, like, left to right, we can say forward propagation, and right to left, we can say backward propagation. Clear, everyone? Little bit overview.
Yes, sir.
Yes, no?
Yes, sir.
Yes, sir. Clear.
Okay.
Yes, sir.
Okay, fine. So yeah, now what I can do, I will share one notebook. Okay, so you can just go through the notebook once and let me know if you face any issue. I will try to explain the everything in a detail, but try to go through once the complete notebook.
Yes, sir.
Okay, now here as you can see in this particular RNN, the first point that we have forward propagation and the backward propagation. Here I mentioned this is the simple type of the neural network. Data follow only the forward direction from the input layer to the hidden layer to the output layer. It may be contain one hidden layer or more than one hidden layer. So here I created only one hidden layer. It might be possible in a real time that you will get n number of the hidden layer. Okay, now for the backward propagation is a method used to train the neural network, and if there are a lot of hidden layer, it may be referred as a deep neural network. Once the forward propagation is completed, we calculate the error, and this error is then the back propagated, where we are going to update the weights. So whenever we are talking about the weight updation, it means we are talking about the backward propagation. So I will share this particular notebook. Just go through the notebook. Okay. Anyhow, in our upcoming session, that we can discuss this one in a detail. Okay. Clear, everyone? Okay. I will start next session from here itself. Okay. But
Yes, sir.
try to go through once the complete notebook.
Yes, sir.
Okay. Fine.
Yes, sir.
Okay. Now, what I can do, I will share one assignment for the assignment that we can share tomorrow. Yeah. Because you already did one. Okay. So yeah, assignment I will share tomorrow. Okay. So just try to go through the notebook, nothing else, for tomorrow only.
Yes, sir.
Okay. Yeah. Let me know if anyone have any query. Just let me know.
No queries, sir.
All good. Jaya Purnima.
Yes, sir.
Okay. Fine. Then let's conclude this session here and see you tomorrow. And tomorrow we can start with the RNN. Just revise this particular notebook once. Okay.
Yes, sir.
Yeah. And most probably tomorrow we have the so tomorrow I will try to stretch the session. Okay. So mostly like 1 hour 30 minutes. Okay. So we are available on time so that we can finish the RNN, because now like as we need to discuss the mathematics little bit, so I need a time. Okay, everyone.
So do we have a class tomorrow or Thursday?
Thursday is tomorrow, no?
Tomorrow is Wednesday, right?
Tomorrow, Wednesday, Thursday. Okay, let's schedule Thursday. Fine, no issue.
Sir, Thursday is Independence Day. We'll take tomorrow only, sir.
Yeah, it's
Okay, fine, no issue. Let's cover then tomorrow. Okay, fine.
okay, sir.
Okay, yeah, but make sure be available on time, because tomorrow I need at least like 1 hour 30 minutes to finish the RNN. Okay, because if I stretch into the 2 session, in this case you can't get anything for the RNN.
Excuse me, sir. Can we do it on 15th, because I have exam tomorrow. I'll not be home early.
Oh, do one thing, just discuss internally and let me know the final date.
Yes, sir.
Okay.
Yes,
I'm
sir.
available, no issues. So just discuss internally and let me know like the final date. Okay.
Yes, sir.
We can continue, no issue.
Thank you, sir.
Okay.
Thank you.
Fine, guys. No issues. So let's conclude and see you. Okay, in our upcoming session. Okay. Okay. Bye.